This is going to be my second stream, episode 1. Because, of course, the first episode was episode 0. Because programmers start at the number 0. That's the way it goes. If you know computer programming and you understand arrays, you will understand why. But in my last episode, I got a very basic program working. I got a program working that created a window and drew a checkerboard to it. And that's just the very, very basic start to trying to make a chess game. I don't have a representation of the chess pieces yet. I still have to code all that. This could take hours upon hours. And this is only episode 1. But I would like to, before I go to bed tonight, I would like to accomplish one other thing. I would like to have some code to handle user input. Now, I'm not going to complete all the interactions from the user input, but tonight my goal is to be able to get the program to register mouse clicks and then print some information to the console based on that. This is a required step, and if I can't get past this step, I won't be able to continue with the game. But I think I have a way to go about it. So I'm going to go ahead and do this stream tonight anyway. So here's my desktop. Now, it's very important to understand that when programming, you have to reference documentation a lot. Because I can pull examples of previous programs I've written and see how I did it and use my own code as documentation. But I cannot do that in this specific case. That's because I need to get mouse input from the user. And I never have done that before in a game. I only use the keyboard exclusively from my previous game. So this is going to be a learning experience. So first of all, let's go to the source folder here from my last stream. So we see that the SDL program compiles correctly. We have a window that says Chaste chess, and we have 2 different shades of gray. But when I click on it, nothing happens. So how do I get some user input? Well, okay, here's the key. I will show you the way. So what you do, if you are using SDL, you go to libsdl.org, and it's important to go to the wiki. The wiki has some very good things. So the SDL wiki, Simple Direct Media Layer 2. Now, SDL2 is the library that I'm using. SDL2 it happens to be the version of SDL. It creates windows. You can draw rectangles to the screen. You can load bitmap images, all sorts of interesting things. But my program is very basic. So we need to go to category, API reference by category. So how do I handle events? So input events. So keyboard support, I already have a pretty firm grasp, although I will show you. I will show you in this example here, there are certain key codes. This is the source code of various things. Actually, a lot of that doesn't make any sense, but see, there are different types of events. So many different kinds of events. So, like key codes, for instance. These are important to know. There's scan codes and there's key code values. You have to put these values into your program to recognize certain key press events. And I know how I did it using my Chaste code, and I can look back at that. But we're not going to be using keyboard for this episode. We're going to be doing mouse input. So it's time to go back to mouse support. Okay. This category contains functions for handling inputs from mice and other similar pointing devices. Please note that this only discusses mice with the notion of the desktop GUI. You usually have one system cursor, and the OS hides the hardware details from you. If you plug in 10 mice, all 10 move that one cursor. For many applications and games, this is perfect, and this API has served hundreds of SDL programs well since its birth. So let's see here. It has SDL capture mouse, SDL create color cursor, SDL create cursor. How does this work? SDL free cursor. See, I didn't do any research beforehand because I want to show you that programming is actually an evolved process. So I'm going to have to go through these functions until I find the right one that does exactly what I want. SDL capture mouse. Okay. Capture the mouse and to track input outside an SDL window. Strange. All right, capturing enables your app to obtain mouse events globally instead of just within your window. Not all video targets support this function. When capturing is enabled, the current window will get all mouse events, but unlike relative mode, no change is made to the cursor and it is not restrained to your window. Let's see here. It's strange. Let's see here. Please note that as of SDL 2.0.22, SDL will attempt to auto-capture the mouse while the user is pressing a button. This is to try and make mouse behavior more consistent between platforms and deal with the common case of a user dragging the mouse outside of the window. That means if you're calling SDL capture mouse only to deal with the situation, you no longer have to, although it is safe to do so. If this causes problems for your app, you can disable auto capture by setting the SDL hint mouse auto capture to 0. But I don't really know if that's what I want. Okay, let's see here. SDL get mouse focus. Get the window which currently has the mouse focus. Okay. I don't really think that's what I need because there will only be one window. What's set cursor? Set the active cursor. This function sets the active cursor to the specified one. If the cursor is currently visible, the change will immediately be represented on the display. Okay, let's see here. Get mouse state. Retrieve the current state of the mouse. Okay, so retrieve the current state of the mouse. Syntax, it's a 32-bit integer. Okay, so the return value returns a 32-bit button bit mask of the current button state. The current button state is returned as a button bit mask, which can be tested using the SDL button X macros, where X is generally 1 for the left, 2 for middle, and 3 for the right. And X and Y are set to the mouse cursor position relative to the focus window. You can pass null for either X or Y. So the X coordinate of the mouse cursor relative to the focus window. Okay, so these are pointers, integer pointers for X and Y. Okay, so here's what I'm going to do. So what I'm going to do here is, okay, I think I have an idea. So I'm going to get started programming here, but this is where it's going to get interesting. So do we have an X? We don't have an int X. Okay, so here's what we need to do. And you will notice if you look at my previous code examples, you will see that I always have like an X and a Y value somewhere. Let's see here, like, let's see here. Okay, yeah, int X and Y. So, like, now in this case, it was, yeah, they were local, but instead, and I could just type it, but I kind of want to look back at my old code just to see how I implemented something. So let's see here. So let's go here. We're going to go, so variables that are usually used for managing rectangles, error checking. Okay, so for right now, here's what we're going to do. We're going to simply use this. We're going to have global integers of x and y. We're just gonna make them global because it's gonna make it easier to manage in the long run. Okay, so first of all, let's set. We're gonna set. Actually, I'm not gonna set those values. Uh, what I'm going to do is this is the game loop here. Okay, this loop here, it continues while the loop variable. The loop variable is 1. And so if something set the loop variable to 0, the program will end. So if somebody presses escape or clicks the window X that has, yeah, then it does SDL quit. So that's what closes the thing. So, but here's the thing. So while we're in the loop, it calls SDL pull event. And then if the event.type equals SDL quit or key up, it does those things. But there are other types of events to capture. So what we're going to do is we're going to leave that there. We're going to leave this part here. Those handle closing the program. But we have to deal with different event types. So it's going to pull the event, and then what we want to do is we want to get the mouse state. So, okay. Let's see here. So we're going to, I know what we're going to do. What I'm going to do here is we're going to want there to be, we're also going to have a mouse state. Okay. So int, okay, so it's, yeah, uint32 SDL get mouse state. Okay, so int mouse state. Okay, we're going to be using that variable later on. So what we're going to do is mouse, we're going to be going through, so mouse state equals, and then we're going to be calling this function. And we're going to be passing in both x and y as pointers. That's what we're going to be doing. We're going to be passing in the pointers by getting the address of operators, what we're going to do. But let's see here. And then let's see, printf. I'm going to be having to use printf. So let me copy my printf statement and modify it. Okay, so mouse position. Okay, we're going to have decimal values displayed. Okay, x equals, yeah, if you don't, it's hard to explain printf. Printf is something you kind of learn if you're a C programmer. You learn how to use printf a lot. So here we're going to do x and y. Okay, let's try this. Okay, so I don't know if I'm doing the code right. Oh, okay, mouse position. Okay, so we have a mouse position. Oh, look, you see that? It works. The mouse position. Yes. Oh. See, and notice that it only updates. Very interesting. That is interesting. Very interesting. See, it only updates when we are inside the window. That's the important thing. So it knows what the position of the mouse is. Now I'm going to try something. What happens if we never actually call the mouse state button? If we never actually get it. So it always says it's 0. It always says they're at their default value of 0. Okay. So what if we do call it, but we only call it outside of the polling for the events? I'm experimenting a little bit here. So what if, okay, because here is where we Okay, we actually, the events are pulled for here. Okay, so yeah, because the part where we pull the events, so there's that. But what if it's called outside of that? Interestingly enough, it still works. I think I did that right. So yeah, it still does. It still does get it, but I'm not entirely sure. See, I don't want it to always report the position of the mouse. We can make it do that, certainly. Hmm. Yeah, we can totally still make it do that. And I'll put it back the way it was, and we'll just make sure it keeps working. But we don't want it to necessarily print the value of the mouse pointer every single time that it goes through the loop, because that would just slow the program down. So what are we going to do here? Let's see here. I'm going to try something. Okay, I'm going to try doing this a different way. Let's see, because there's more than one way to do this. Let's see here. Is there, let's, let's get, let's see here. Steal button macros. Let's see here. Get the current state of the mouse in relation to the desktop. Oh, that's get globe. So that's related to the entire desktop, not just the window. Okay. Hmm. Hmm. Okay, so let's see here. How do we handle this? Because I've never really done this before. This is a very interesting learning experience. Let's see, what's show cursor? Oh, this is whether the cursor is shown. Okay, let's see here. Let's see, mouse support. Okay, let's see here. Because I want to understand, okay, event handling. So, event type. Wait a minute. Ah, mouse button events. Okay. Let's see about the mouse button event. 'Cause there's mouse motion events. Hmm. Hmm. I'm trying to understand this. Because I don't know if I need to use this, but it might be a good way to do it. It just might be. So, let's see. Mouse button event. Okay. Oh, okay. The event type, mouse button down or mouse button up. Okay. Okay, so here we have, okay, the state of the button, SDL pressed or SDL released, clicks, 1 for single click, 2 for double click, X coordinate relative to window. Okay, SDL mouse button event is a member of the SDL event unit and is used when an event of type SDL mouse button down or SDL mouse button up is reported. You would access it through the events button field. Button may be one of yeah, okay. 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 Button may be one of SDL button left, SDL button middle, SDL button right. Okay. Let's see here. So, it doesn't look like I technically will need this mouse state thing, not necessarily. I may not need that. I may delete that if I don't end up using it. Okay, so here's what we're going to do. So the event is simply named E. So what we're going to do here is if E.type equals mouse button down. And also, I want to show an example. Let me go back to Chaste just because in here we had examples of, okay, so a case if e.type equals SDL key down. So instead of SDL key down, it's mouse button down. So that's just an example, and I had different cases for different keys that were pressed down. But mice are actually simpler than the keyboard because they only have a few buttons. So what we're going to do is if, okay, so if e.type equals mouse button down. Okay, all right, so we're going to do this. We're going to try something here. If e.type equals mouse button down, what we're going to do is I'm going to just do a test. So we're going to, so let's see here. Interesting. I noticed that, okay, whole event E. So if e.type equals SDL mouse button down. Oh, and then, oh, I see how it is. It's not, we're not going to be testing the key sim. So we're going to not test the key sim. We're simply going to do loop equals 0. So let's try this. Oh, okay, I did it. So I right-clicked the mouse and the program closed. I left-clicked the mouse and the program closed. But I don't want it to, I don't want the program to close. That was just a test. Okay, we're gonna cancel out the, actually, we're not gonna do that. So here's the thing. So we're going to do, okay, so we're going to simply say, for this case, mouse clicked. Mouse clicked. Okay, and we're going to get rid of these. So we're simply going to have it say the mouse clicked every time it was a mouse button down event. So no matter whether I do right, middle, left click, it just says mouse clicked. Okay, that's cool. That's actually very cool. So what happens? Actually, I'm gonna try something. So I'm gonna hold it. Okay, so it does it. So what if it's a mouse button up? Okay, this is gonna work. Okay, mouse button up. Okay, so now I hold the click, and when I release the click, then it does it. Okay, but we're gonna change it back to mouse button down. So it's displaying a message. Okay, that's how we're gonna do it. So now we have to get the data field. So let's see, does it have an example? Okay, you would X through the events button field. Okay, so button. Okay. Okay, so let's try something. Okay, so if e dot button equals, okay, SDL button left. Okay. Okay. Then we're going to print okay. Okay. Wait, okay, I didn't mean to do that. Okay. SDL button left. Okay. We're simply going to print wait a minute. Uh, let's see. I may be doing this wrong. Okay, the button that changed. Um, I don't know what I'm doing. I really don't know what I'm doing here. Let's see. Okay, so let's see here. I'm trying to understand. I need an example. I totally need an example, an actual code example, because I'm not sure if I'm doing this right. Um, event dot, because event dot type, event dot button. Hmm, that's strange. Okay, let's see here. I wish there was an example. Okay, SDL mouse input uh example. Okay. Okay, so let's see here. Event type SDL quit, SDL mouse motion, and p event dot button dot button dot button dot button. Huh. Huh. Uh dot button dot button. That's weird. I don't understand. Why is there a button of the button? Okay, I'm gonna try something. So we're gonna try e dot, just as there was e dot key dot keysim dot sim. That I don't understand this, but e dot button dot button equals. Let's try this. Oh, hey. See, when I right click, it does mouse clicked, but it doesn't say anything else. When I do left click, it says SDL button left. Okay. So I don't know why it worked that way. Okay. So mouse clicked. Okay, so here I'm gonna just modify this a little bit because I like to split my printf statements. Okay, so if e dot button dot, all right. So what we're gonna do here, I did not mean to delete that. Okay, I meant to copy this. Okay, so if e dot button equals steal button right button right. Okay, let's try this. So we have left, right, left, yeah. Mouse clicked. SDL button. Okay. Oh, nice. But I don't have anything. If I wait. Huh. Interesting. Trying to see about the. Huh. It's actually very interesting. Let me try. Okay, so if I go back here, it could be SDL. Okay, SDL button. Okay, SDL button. Steel button middle. Let's try, okay. Let's try middle. Okay, we're gonna try middle. Left, right. middle. Okay, so we're going to have middle. And we're going to change this to middle as well. Let's see if my mouse even has a middle button. Kind of has like a scroll bar, but I don't know if that counts as a button. Okay, we're going to try this. Okay. Ooh, nice. So now, if I can middle click, middle button, right button, left button, middle button, right, left, middle, right, right, middle, left, left, middle, right, left, right. Okay, so now you can see whichever on the screen every time I press every time that I press a button, then we're going to get a display of which button is pressed. Now, here's what I'm thinking. I'm thinking that right now it doesn't actually matter which button is clicked. I'm going to have them all behave the same. Or maybe just left, I'm not sure. I could keep all the same just to be sure. Okay. All right. So, yeah, I'm not even sure honestly. Actually, hmm. Yeah, well, I still have to decide how I want to handle this, but so now we have to make sure we have a way of getting the x coordinate relative to the window. Okay, so mouse button event. Okay, event e dot x. Okay, so here's what we're gonna do. Then what we're gonna do is okay, so we know there was a button down. And those are simply statements that print based on which key it was. But what we're going to do now is x equals, okay, wait. Okay, x equals, okay, e dot x. First let me just compile that and see if it does anything. Okay, okay, e dot button dot x. Okay, let me just dot button dot x. Let me try that. Nope. Okay, so that doesn't work. So I'm still not sure why it works the way it does, but let me try this. Now let's try this. We're gonna copy the statement I made earlier. Um, okay. Click at position. We're gonna try this. Okay. Notice that it doesn't update the y value, only the x. Ah, that's just totally fine. That's totally fine. Click at position. Okay, here's what we're gonna do. Okay, mouse clicked. Um, okay, mouse clicked at position. All right, here's what we're gonna do. We need to make sure that we get the x and the y value. Okay, that's what we're gonna do. So, if okay, what we're gonna do when there's a mouse button vent down, we have mouse clicked at position. Actually, let's combine this printf statement. We're just going to have, it makes so much more sense to just combine it all in one. Mouse clicked at position. Yeah, let's just condense this. It's going to make it look so much better. Okay, mouse clicked at position XY. And then, let's try this. But we want to condense the output even more. So what we're going to do is we're not actually, wait a minute. Yeah, let's remove the new line there and make that a space. And let's try this. I'm just customizing the output here. But see, those all have new line characters in them. So I see, right. See, this is why programming takes a long time. I'm trying to get it just right. Okay. So now, oh yeah, that's acting very weird. Okay, so what we're gonna do is we're simply it's displaying all that, and then we're going to simply do one printf statement with nothing except the new line character. That's what we're gonna do. After it prints out all the information on one line that we want. Okay. Okay. Yeah, see that? Now every single line, mouse clicked at position and it tells the pixel position. It also doesn't do anything if I'm in a different window. Yeah. It only does it from within that other window. So this is actually cool. We have some basic user input. Yeah, this is actually really cool now. Let's see here. How long have I been streaming this episode for? Okay, I've been going for 37 minutes. I need to use the restroom. And then when I come back, I'm going to do something. I'm going to improve upon this program. But for right now, we have a basic program that actually works. And we don't actually need these because we're now handling the events with different code. So I'm going to delete that unneeded code. And then I'm going to improve upon this once I come back from the bathroom. All right. So now we have a basic working program that will print a message which button, whether it was left, right, or middle, was pressed, and at what pixel location. Okay, now here's something I need to do though. So actually, I need to look at a chessboard. Instead of going to my image, I'm just going to go to chess.com. I'm going to go to an example. Any example will do, in fact. Ooh, it's time to make my move with Anastasia. Okay, this is cool. So, oh, it looks like I'm playing black in this game. So this might not because I'm used to the orientation of white, and you'll notice that it goes A through H here. Yeah, so it's different when I'm playing as black. But anyway, I'm going to make my move against Anastasia here. Yeah, okay, this is, oh man, this is so, yeah, this is weird, man. I tell you, this is, yeah, I could totally lose this game because this has not been one of my better games. Anastasia could actually win this one. Um, let's see here. Yeah, oh yeah, this is a tricky one. This is very tricky. Hmm. Hey, I know. I think that I will want to move this. I think I'm going to move that bishop there. No, I'm going to move the bishop here so it's still defended by the pawn. So yeah, I need to look at an example. Okay, this is fine. See right here, this screen? From when you're playing as white, notice what the letters and numbers here. So A through H. So every square on the chessboard has an A and a it has a letter and number. So A1 all the way to H8. So here's what we want to do is, okay, and also I want to look at something else. So let me run my program again. Okay, now let's look and see. Notice that we have two colors here. We have a lighter gray and a darker gray. But notice that the darker gray is in the top left in my program, and the lighter gray is in the lower left. But I'm going to position my program relative to the way this looks a little bit differently. So I'm going to edit my source code, and we're going to change the colors. We're going to change the colors here. So let's change, what we're going to do is we're going to move this color to over here. And now this color here, I just have commented out. I'm not using that one. Okay, so then, okay. Okay, and I hope I've got this right. I hope that I've got it right here. I want it to look according to the orientation of playing as white. Okay, so let's see here. Let's run the program again. So now you'll see, okay, so top left is light gray. And it's different shades of gray, of course. It's totally different shades of gray than what it shows on here, because I'm not using the exact same colors. I don't have to. I just kind of want to make it a little bit different, if you know what I mean. Um, hmm. Yeah, okay. So, and I can change the colors too. In fact, I want to try something. I'm just going to try something here. Let's try, okay, let me just try, I'm going to copy this. Try CO. Okay, I know what. Okay, I know what I'm going to do. Because I just want to try something. I'm still playing around with the colors. So let's see here. We have CO, CO, CO. Okay, let's see here how that looks. Because I like playing with the colors. Okay, that's interesting. Okay, CO, and let's try here what we're gonna do. Let's try. See, I can totally modify the colors at will depending on what I feel like with how it works. Of course, this code will need to be modified anyway, for sure, later on in the program. This is just the very start. Okay, so let's try 40, 40, 40. Because the program's going to go under... Okay, now that actually looks pretty cool. See, but the only problem with the way it looks here is that the light is so light and the dark is so dark it's almost black and white. So that doesn't prevent, it doesn't have enough contrast, you see. So the way that I had it originally is actually better. So I think I'm going to still keep these in the code, but only as examples. These are simply going to be examples of possible color values, but I'm not going to use these in the game. These are simply going to be some examples only of possible color settings. In fact, I could do some modifications, like if I wanted to just have a single gray value and then change that. That would work too, but that's more of an advanced thing. I don't need to do that right now. Okay, anyway, let's go back. Here's the original look. So now you see that, like this chessboard example, the light gray is at the top, and the lower left is the darker gray. So now we need to have a way so that we can sort of represent the we want to be able to know which... Okay, if we click on a square, how do we know what the identity of that square is? And also, we know it goes from A to H, left to right, and then down to up is 1 to 8. So let me just look quickly at chess notation, because if I just Google chess notation, so okay, let's see, let's go to Wikipedia. Okay, so it shows here, it shows how this is. It shows the algebraic notation, standard method for recording and describing the moves in the game of chess. It is based on a system of coordinates to uniquely identify each square on the board. It is used, let's see, used by most books, magazines, and newspapers. So it has a standard system. And yeah, every single piece has a letter name. Okay, each piece type other than pawns, and I think pawn should have P, but typically they're not even, P isn't even used. They're just kind of not use a letter for pawn. But K is for king, Q is for queen, R is for rook, B is for bishop. Hey, isn't that cool? Every time you hover over, it shows an image of a chess piece. Wikipedia has articles for every chess piece. This is actually super cool. I've just never really looked at this. But yeah, I'm a little bit familiar with chess notation. And I'm not implementing full chess notation in my game. Let's see here. But we have a basic look. So here's what we need to do. First of all, what I'm going to do is we're going to have a system, because now I have a working example for the mouse button. In fact, I don't even need this page anymore. I don't even need this page, because now I have all the code that I need for this program here as far as the mouse input. So so now we have mouse clicked at position X and Y. So it tells the pixel value. But what if instead of it telling what the what if we don't want it to tell the okay, yeah, so that's what we're going to do. What we're going to do is, instead of it telling us the pixel position, and we can still leave that in there. Okay. Then what we're going to do is we're going to also have a separate part of this. So we're still going to continue this after it prints that part. then what we're going to do is we're going to, so, okay, I'm trying to think how this works. So we have the x and y values, and we've printed them, but now we can change those values at will. So what we need to do is the square size. Okay, the square size I happen to know is 90, but what we're going to do is we're going to use the square size. So let me go back to the actually the square size. So the main check.rect size equals height divided by, and I happen to know that 720 divided by 8 is 90, but we don't need to use the actual value. So what we're going to do is we're going to do, okay, so x equals, okay, yeah, okay, so, okay, x equals width divided by main check rect size. And, okay, that's good. And then we're going to have y equals height. And this would be, it's the same value in both this case, but I'm still just being consistent using y for the height and x for the width, even though they are the same. Okay, so yeah, it's still, okay, we have, it, so far nothing has changed about the display. Okay, so then we're going to have another printf statement. So, okay. So, okay. Okay. Then we're going to have square clicked. Okay, square clicked, and it's going to have, yeah, okay, we're gonna keep those there. We're gonna still, yeah, we're gonna have that. We're just gonna have a very simple thing here. I'm gonna try this. Okay. Ooh. Oh, wait a minute. Ah, wait. Oh, that's right. Oh, of course. Because we need to divide. Yeah, okay, yeah, that's right. We need to divide it by, oh, okay. Okay, yeah, I need to figure out the math in my head here. I'm getting confused. So, because, okay. Okay, let me try something. So, okay. Width divided by rect size times x and rect size times y. Let's see here. Let's try this. Oh, okay, wait a minute. Yeah, that's okay, yeah. I'm trying to think here. I'm trying to think here. So, okay, here's what I'm going to do is I'm going to use separate values here. What I'm going to do is we're going to have a separate, we're going to have x1 and, okay, yeah, we're going to have x1 and y1, just so that we're using different variables here. Okay, so here's what we're going to do. We're going to have x1 and y1, but we're going to, let's see here. Okay, so we need to divide it by, oh yes. Wait a minute. Okay, yeah. Okay, I think I figured out the formula. So we have, okay, x divided by main check.rect size. Okay. Yeah, okay. All right, then we have y divided by, okay. We're just going to use separate, okay, that's still showing x and y. Wait a minute. How come the value is always the same? Oh, wait. Huh. That's weird. That's actually very weird. Oh, that's right, because yeah, clearly there's an error in my code there. Wait a minute. Oh, of course, because it has to be e dot button y is when we first get the value. Okay, so yeah, so they're not always the same. So now we're gonna be printing x1 and y1. Okay. Okay, so now notice this. Notice now what we have is the top left is 0, 0, and the bottom is 7. So we have 0 through 8. So here's what we need to do. What we need to do is we need this square to be okay. Trying to figure out the way to do this. So okay, let's start on the letters first. Okay, let's start on the letters. So we know that that the bottom left is going to be represented by A. We know that. X should be a fairly simple calculation. So then what we're going to do here is, okay, so square clicked. Yeah, so that's still showing it in the Cartesian coordinate system. That's what it's showing. So that's correct, but it's not the chess board notation. So first we're going to, okay, so we're going to, okay, we're going to call that Cartesian square clicked. Okay, and then we're going to have a separate one. So chess square clicked, what we're going to do is we're going to be printing characters. We're going to be printing characters instead. And this, okay, this is going to be weird. And it's probably, okay, yeah, see, it's not going to work there. What we have to do is X is going to be A, the character A, the character A plus x1. That's what we're going to do. Notice, okay, now notice that when I click X, the X value there shows the letters. So A, B, C, okay, A, B, C, D, E, F, G, H. Now we have to do Y. Now Y is interesting because notice that Y is 7 here, but it should, instead of 7, it's 7, 6, 5, 4, 3, 2, 1, 0. But that's not the way it needs to be. Because if we look back, actually, well, I don't need to look back. I remember that it's supposed to go 1, 2, starting at the bottom and going to the top. So here's what we need to do. We need to change this, actually. But, oh, that means we're still going to be displaying a decimal value rather than the character. We're still going to be displaying a decimal value for y, but we're going to be changing the fundamental operation here. Okay, yeah, okay. So, and we don't even have chess pieces yet. We're just trying to do a representation here. So here's what we're going to do. Let's try, so chess square clicked is going to be 8 minus y1. Okay, let's try this. Notice that. So y1, y2, y3, y4, 5, y6, 7, 8. Interesting. Now, okay, what if I had done 7? What if I had done 7? Let's just try that. And 0, yeah, 0, yeah, so 0, 1, 2, 3, 4, 5, 6, 7. But it goes 1 through 8. So, let's change it back to the way it was. So now see what we have is it tells us the mouse pixel position, what's clicked. Okay, let's look at this. It tells us what pixel position, and then it tells the Cartesian coordinates of the squares, like, yeah, as if they're, 0 through 7. So it does that. So it clicks correctly and tells me the information, but then it tells me the rank and file of the standard chess notation. So A1 all the way to H8. So now I can click on the chessboard and it will tell me. So now, okay, so we have it working. So now here's what we're going to do. Now what I'm going to do is we're going to comment out the other printf statements. And I'm just gonna print. Actually, here's what I'm going to do. Instead of commenting out each individual statement, what we're actually going to do is we're actually going to okay, that's what we're going to do. We're actually going to, all of these printf statements here are going to be commented out. We're going to comment out this whole thing. Okay. So now it tells only the Cartesian square clicked and the chess square clicked. And then we're going to comment out the, actually, you know what I'm going to do? I'm going to change this. I'm going to comment this one out separately. Then I'm going to comment out this one here. And then we're going to, because I'm just trying to selectively do this. And none of this will be relevant to the final game, assuming there is a final game. But, so now it only says chess square clicked, x equals a, y equals 1. Okay. So it says, all right, that totally works. So x equals a, y equals, so it tells exactly which, it tells the exact, it tells perfectly, it tells absolutely perfectly what the, and I can make it capital too, because I understand how character values work and everything. We're just going to do the capital character of A. And now we have that. It tells which chess square was clicked. But we don't actually need that for the final game necessarily. I keep talking as if there's going to be a final game. I don't know if there's going to be a final game or not, or if this is even going to become an actual game. But I'm getting the mouse input working. So now we have a way to know that it works. We know that it works, but how? Okay, now here's a very, very valid question. We want to be able to highlight. We need a visual representation on the window itself that particular square was selected. So here's what we're actually going to do. What we're actually going to do is we're going to be using the rectangle. So what we're going to do is we're going to first, we get the x value, because the x1 and y1. These are, okay, we're going to be using the Cartesian coordinates for x1, y1. That's what we're actually going to need here. These are going to be important. So what we're going to do, we need we need to use x1 and y1. So what we're going to do is, okay, rect dot x equals x1 times main check rect size. That's what we're going to do. And then we're going to change this to y and y. And then what we're going to do is we're just going to make sure, okay, let me go back to my other source file. Okay, yeah, I'm going to close out of that because I don't need that open right now. We're going to go back here. And even though now for my checkerboard function, you may notice that I just optimized rect w and y to be main check rect size and main check rect size at the beginning and not change the loop. That's because that was a very simple loop. And we didn't need to repeat ourselves. But in this case, for the sake of readability, we're going to make sure that regardless of what else is happening in the program, these four attributes, x, y, the width and height, are all set. So then what we have to do is we need to be able to draw a color. Yeah, we absolutely need to be able to draw a color on that square. So we're gonna have to choose a color to draw. So here's an idea. We're going to see, I knew these would come in handy. We're going to set medium gray. We're going to use medium gray as the color value. Okay. We're going to set the render draw color. Actually, I'm going to try something here. I'm going to run it as it is. Yeah, that doesn't do anything because we haven't drawn anything. We also need to render the fill rect. So what we're going to do, actually, let me. Okay, I'm going to comment this out and just see what result we get, because if we don't draw that, then it does a weird thing like that. It leaves that part as black. So back to that. Okay, put that back as it was. Okay, that's good. So now, but SDL render fill rect. Yeah, we're going to, and we want to make sure we set the draw color, and then we render that, but we need to make sure that we are giving it the address of the rectangle pointer rect. So actually, what happens if I just do rect without the address symbol? Ooh, incompatible. Yeah, expected constant steel rect pointer. So it has to be a pointer. So we need to make sure we use the address of operator, because the ampersand has some many multiple uses actually. Okay, so even though we tried to draw it, nothing's showing up on the screen. Why doesn't it look different? Well, that's because we have to render present. Okay, render present is very important. This refreshes the screen. Okay. Okay, and this message there. I'll still include that, but this will simply be okay, so only if the window is successfully created, then we'll print that message there. Okay, so but we still don't have any visual changes on our screen yet. So what we need to do is we need to call render present, because we called render present here. Let me show you an example. If we delete render present and we don't refresh the screen, you see how this is? The window is blank and it has whatever was behind it. Isn't that freaky looking? That's not the intended behavior. We don't see our checkerboard. So first we need to put the render present back where it was, and then we're going to copy it And after we've set up the rectangle, then we set the render draw color, and then we fill that rectangle with those given values in that rectangle structure. Then have to, oh, interesting. Now notice that every time that I click a square, it changes the color of that square, but then it doesn't remove the previously done one. So here's where it gets interesting. We're going to have to do something. We're going to have to change the program fundamentally so we know which square was clicked. Okay, that's what we're going to do. So now what we're going to do, here's where it's going to get interesting. We're going to be moving, we're going to be moving our code into the game loop. So what we have is, okay, so what we need to do is, actually, I need to use, I need the syntax highlighting to help me see this better. I need my syntax highlighting. So let me open this in Visual Studio Code. Wait a minute. Wait, this is the wrong source file. That is not what I intended. Okay, I need to open the folder that I'm currently in here. We're going to open this folder. Okay, that's nice. And then we're going to go, here's main.c. And it's going to give error messages. That's not important right now. The main thing is we simply need to see, because I've closed the other text editor, we need to make sure I'm putting things in the right spot. So we need to highlight, so SDL poll event. So all of everything in the loop. Okay, wait, actually the loop. So let's see here. So what we need to do is we're going to move everything here. We're going to put it here at the end of the loop. That's what we're going to do. Let me make sure that's right. Okay, so now we have, it will always present after, at the end of the current loop, it will always present. Oh, wait a minute. Oh, wait a minute. Oh, see, we have a problem. We have a real problem. I messed this program up big time. I totally messed it up. Okay, that is not the behavior we want. That is so not the behavior we want. So here's what we actually have to do. Because we don't, it's wasting CPU cycles. We don't want that at all. Let's put this back the way it was. So we don't, because in chess, only when something is clicked and moved do we need to update. There's no reason to update the screen unless something is changed. But because we have overwritten the checkerboard, we need to redraw the checkerboard. Now, because none of the values have changed in our checkerboard, we have an initial checkerboard. Let's call the chaste checker function here again. What we're going to do is we're simply going to, so what we're going to do is, if there is a mouse button down, then we are going to, then we're going to call the, then we're going to recall the chaste checker function. That's what we're going to do. Ooh, interesting. Now we have a different problem. We have a very, very different problem here. There has to be a way to fix this. See, because now we don't have the code before and after. Okay, so here, see, these other things. Okay, these are cool. See, because the actual we need to redo. We need to fill the screen with one color, and then we need to Yes, then yeah, that's what we have to do. All right, so what we're going to do is, okay, what we're going to do is we're going to initialize the checkerboard at the beginning of the program. We won't really need to touch that afterwards because we're not going to be changing the values. We're just going to initialize the checkerboard. And then what we have to do is we have to have, okay, yeah, initialize the checkerboard, set up the checkerboard at the beginning of the program because that doesn't change. And then we have SDL set render draw color. It has that color there. And then we we do that, then fill the rect, and then so we're going to call all four of these. So look, okay, so first, yeah, see, programming is more complicated. So right now, see, it doesn't work because it updated the fill color. So what we're going to do is we're simply going to copy all four of these. We're going to copy all four of these. We're going to go, if there's a mouse button down, we're going to call all four of the functions. All right, that's how it's going to work. By the way, I really like this theme I have. I forgot how I installed it. Let's see here. Okay, so this is the Mac Vim Ron theme. Mac Vim Ron theme. I just like this theme for the color coding. So yeah, Control KT takes the theme browser, and so you can have different themes. But Mac Vim Ron just looks cool. I like the color scheme. I don't know how to make my own themes yet, but I feel like this is a good thing. Okay, so now when we first start the program, it starts like this. And now, oh, can you see that? Can you see how as soon as I click on a square, it highlights that square, it redraws the entire checkerboard, and then it simply, yeah, it redraws the entire thing. That is so freaking cool. Now, there's another consequence of this. So let's say that we drew the checkerboard at the start, but we wanted to draw it as a different color here. So first we draw the checkerboard, but then, oh, see, now it's changed the color of the checkerboard now that we started clicking. It looks really cool, but I'm trying to stick with shades of gray. I'm trying to make this be Game Boy type theme and for colorblind people who only see shades of gray. So that's why I'm trying to go for what I'm going for. But okay, let's set this back to the way it was. So we have light gray, dark gray, and medium gray as selection. It should be easy for colorblind people. I hope so anyway. I really genuinely hope so. And now that we have it correctly selected, we don't necessarily have to have it say the Cartesian square clicked. We don't need to have it display that every single time. So we can remove that. But before I do that, what happens if this function draws a checkerboard? It is highly optimized because it does not switch colors during the function. It only draws half the checkerboard squares and leaves the remaining areas the same as the background. So it just uses the current draw color. And then, for example, yeah, note that's interesting. I noticed that these don't have descriptions, but my function does. Okay, let's look at the initial state drawing checkerboard the whole screen. Okay, that's cool. So, but so it uses my own comments that I wrote. Okay, Visual Studio Code is actually pretty cool. I will admit, it's cool. It works on Windows, Mac, Linux. It's cool. So what happens if we comment out the chase checker function? Then what happens? Then, see, it only draws the square. Yeah, it only draws the square there if we do it like that. Only that specific square that was chosen. That's actually very cool. So this is how I can select a square. I can click within a certain square. But let's try this one. Let's try commenting this one out. Oh, yeah, you see how that is? Now they don't go back because the background has not been. Yeah, that's very weird. So yeah, but this is the way it's supposed to be. So now see, we can tell we have a visual representation of which square is currently selected. And of course, I could also make it more visually appealing. All I have to do, let's change this to a 0, and then we will get a bright purple color. Actually, oh yeah, it's a darker magenta. But so now it's much easier to see than using a medium shade of gray. But I also kind of want this to be like a colorblind thing. I want it to be a shade of gray thing. But I can change the colors at any time. That's the beauty of computer programming, is I can totally change the colors. So we have the right thing. We have the right thing here. So now let's change it back to an 8 there. And notice once again, if we don't redo the render present, nothing happens. The render present is important. So you have to learn about, drawing graphics in STL, but it definitely works. Because you have to set the draw color, then you have to set up the rectangle you want to draw. What's the structure? And you have to, drawing a rectangle, yes, it's kind of a complicated deal. But I like this. I like it because it lets you set these 4 elements, and then there's no questions about what the rectangle is. Okay, so, oh, and then also include errors. Please update your include path. Okay, add to include path. Yep, I'm adding I'm adding the workspace folder and user include SDL2. Okay, that's cool. So now that I've done that, now we have no errors displayed because it updated the path. So now what we have is Cartesian square clicked. Okay. So now we have so what I'm going to do here, we're going to do chess square clicked. I am going to have it display which chess square was clicked. I'm just going to have it display that. Yeah, it is displaying that. So you can see which thing was displayed. In fact, we don't even need the X and Y there now. Now we don't even need that. But also, let's try something. What happens if I reverse the Y and the X here? Wait, that's the wrong function. No, that was the right function. Okay, I'm just going to try this because I'm going to mess it up intentionally just so you can see what it looks like. Now we have H8 there. Now it's backwards. See how it's backwards now? So now that is A and this is H, but it goes the wrong way. And then yeah, so basically it's kind of like flipped. That's like almost like Black's view. That's kind of funny how that is. But yeah, so all right. So now what I'm going to do is I'm simply going to remove the X and Y components here. We're simply going to have it tell which square was clicked. It's F4, C3. I still think having a space between them is helpful, It is helpful, absolutely. It's super helpful. But it tells which chess square was clicked. So now, not only do I have a chessboard, I have a program that gives a visual representation. It changes the color of that square, draws a medium gray square there, and then it tells me which chess square was picked. This is actually extremely cool what I've done. So now I have a chessboard with no pieces, but I have mouse input. This is really, really incredible stuff, people. I really hope that people do watch my live streams of programming this because this is cool. This is only episode 1 and I already have a representation. You can see the colors change. Oh, this is nice. Yeah, hoo-hoo. I can click anywhere I want and change the color of the square. So now I have a representation of this. So that means I still have to add pieces. I still have to add pieces to my chess game. And I have to have a representation for those pieces. So that's where it's going to get a little bit tricky. So, but I better end this stream for now. But I've made a lot of progress here. I'm very proud of what I've accomplished so far. It tells me which chess square was clicked, and there's a visual representation. The work on Chaste chess, my chess game, is progressing. It won't necessarily have a computer opponent, but I can play it against myself just as if I had a regular wooden chessboard in front of me. So that's all for now, and I really hope somebody has enjoyed my live stream, and there will be a video recording of this, as always. So thank you for watching or listening, whatever. But actually, you want to watch it. You're not going to understand what I'm talking about. So that's all for now. Oh, about an hour and a half. Good night, everyone. And leave me comments, questions, whatever you have about my programming stuff. And also, follow me on Twitch and Patreon. I am not hard to find on social media. Chastity White Rose is my username. And Chastity White Rose Programming is my Patreon. And I share the links very commonly. My Twitch profile has all my social links.